Usually when you hire someone to build a house, there's like a pretty standard expectation for how that whole relationship is going to work.
Right, yeah.
Like you hand the contractor the finalized blueprints, you shake hands, and, well, they go off and build it.
Exactly. You just let them work.
Right. You expect to just walk away and come back, I don't know, 6 months later to a pristine, finished house with everything exactly where the blueprints said it would be.
Yeah, because the planning phase is, it's entirely walled off from the execution phase.
Mm-hmm.
And that separation is really what gives the person paying for the project peace of mind. I mean, the decisions are made, the ambiguity is removed, and now it's just, simply a matter of pouring the concrete and hammering the nails.
But imagine if you hired this, like, world-renowned master builder, right? And you handed them those massive, perfectly detailed blueprints, and instead of just getting to work, they started texting you every 5 minutes.
Oh, no.
Yeah, like, should this brick be slightly more red? Or, ooh, I see a tiny contradiction on page 42 of the plumbing schematic. Do you want the pipe routed over or under the beam?
Yeah, that would entirely defeat the purpose of having a blueprint in the first place.
Exactly.
You'd feel like you were micromanaging the whole project, basically forced to supervise every single hammer strike instead of just letting the expert do the job you actually hired them for.
And that tension, that exact feeling is what we're diving into today. So welcome to the Deep Dive.
That'd be...
Today, our mission is to explore a really fascinating, incredibly in-the-weeds experiment from a developer who tried to force a cutting-edge AI, specifically Claude Code, into a really rigid, old-school software development workflow.
Yeah, we're essentially looking at what happens when unstoppable modern AI collides with, well, the immovable object of traditional project management.
Right.
And the stakes here are incredibly high for anyone listening who manages technology or teams.
Oh, for sure.
We aren't just talking about writing lines of code here. We're really examining the messy, real-world transition period between human-led project management and AI-led execution.
And uncovering all those hidden friction points that nobody really warns you about.
Exactly.
Okay, let's unpack this core conflict right away.
Right.
The developer in our source material was attempting to use a strict SDLC, a software development lifecycle approach.
Right, the classic waterfall.
Exactly. For anyone unfamiliar, this is the classic waterfall methodology. The philosophy is that you figure out like every single requirement, every problem statement, every database table, and every architecture diagram completely up front.
Yeah, you get all the stakeholders to sign off on this massive document.
Right. And then you just build it sequentially, step by step.
And this framework has dominated traditional enterprise teams for decades, really, because it mitigates risk. You absolutely do not want human developers writing expensive code until everyone agrees on what the software is actually supposed to do.
Right, because changing your mind halfway through a waterfall project is notoriously costly.
Oh, massively costly.
But the developer explicitly notes a major roadblock right out of the gate here. Claude Code is natively designed for what the developer community calls vibe coding.
Ah, vibe coding. Yeah, it's a relatively new paradigm, but it is fundamentally how these large language models operate best.
Yeah, it basically means that the development process is highly interactive and conversational.
Right.
You don't give the AI a massive blueprint.
Right.
Instead, you give it a general idea, a vibe, and it constantly asks you questions, clarifying along the way.
It wants to collaborate.
Exactly. It wants to bounce ideas off you.
Yeah.
But our developer explicitly didn't want a collaborator. They wanted to hand over the finalized specs and just walk away.
And this friction highlights a huge issue in current AI workflows. I mean, an AI model thrives on immediate feedback. It wants to resolve ambiguity the second it encounters it because, well, that prevents it from hallucinating or going down the wrong path.
Right.
However, human enterprise systems are built on these massive, finalized requirements designed to eliminate conversation during the building phase.
Which brings me to a major question. If I'm paying for an enterprise-grade AI, and it constantly wants my input on every single virtual brick, isn't forcing an interactive AI into a rigid waterfall box entirely counterproductive?
Well,
it just feels like we're applying 20th century management techniques to a 21st century intelligence,
Oh, absolutely. And the developer's experiment proves that point in real time.
Yeah.
By forcing the waterfall approach, the AI couldn't just flow. Using the SDLC framework slowed the development process down into an enormous number of separate, broken up sessions.
Wow.
Yeah, it completely negated the speed advantage that vibe coding usually offers. But the developer was determined to make it work, though. specifically to maintain complete architectural control over the final product.
And to maintain that iron grip on the architecture, they had to prep the context. They had to feed the machine the
Yeah,
blueprints.
to the setup phase.
Here's where it gets really interesting. This part of the experiment absolutely blew my mind.
Oh, yeah.
The developer started with nothing but a raw transcript from a kickoff meeting.
Just a transcript.
Just a transcript. From that single, messy human conversation, in less than 2 hours, they used AI to produce a massive, comprehensive requirements document.
That is wild. I mean, the sheer scale of what was generated in those 2 hours is staggering.
Yeah.
We're talking about detailed problem statements, user journeys, mapping out exactly how a customer clicks through the app, business process flows, and comprehensive API definitions mapping out how the software talks to other software.
They even had to generate a full architecture model, specifically a C4 model structured in AR42 format.
Okay, that's heavy.
Right. For anyone scratching their head at that acronym soup, the C4 model is a way to visualize software architecture from different zoom levels, like zooming from a world map down to a street view.
That's a good analogy.
And AR42 is basically a strict text-based syntax. It allows a developer to write out architectural building blocks in plain text, which a system can then read and render into a beautiful visual diagram.
Incredible.
They had all of that, plus a data catalog, a graph database model, and low and high fidelity wireframes. 2 hours from a meeting transcript.
Any project manager looking at a document that perfect would naturally assume the AI coding agent could just ingest it, understand the whole picture, and, start building the application.
Right, but it couldn't.
Wait, really?
Yeah, the AI actually choked on this massive monolithic document. To get Claude Code to process the instructions without failing, the developer had to take this beautifully comprehensive document and painstakingly chop it up into tiny, bite-sized markdown files.
Oh, man. So the requirements, the wireframe lists, and the business process flows all had to be stripped down into separate, simple text files categorized into highly specific folders.
Exactly. They even had to create a reference catalog, basically a table of contents, just to help the AI map how all these tiny files connected to each other.
Wow.
I have to challenge this whole premise, though. We're constantly told that modern AI can pass the bar exam and read entire books in seconds.
Right.
Why did the human developer have to meticulously chop the documentation into tiny text files like baby food? Doesn't that manual labor defeat the whole purpose of automation?
It definitely seems counterintuitive. But until you look at the fundamental mechanical reality of how these models process information, it doesn't make sense. It all comes down to the context window and the attention mechanism.
Okay, let's break down the attention mechanism.
Sure. So when you load a massive monolithic document into an AI's context window, its attention gets diluted across thousands of words.
Okay.
It's kind of like asking a human to read an encyclopedia and then recite a specific recipe from page 400 while simultaneously remembering the history of the Roman Empire from page 10.
Oh, I see.
Yeah, the AI can lose the thread or worse, hallucinate connections that aren't there, like confusing a login protocol with a payment gateway, simply because the text was located nearby in the massive document. So by breaking the project down into bite-sized markdown files, the human developer is acting as an information architect.
Exactly.
They're controlling exactly what the AI reads at any given moment.
Right. They ensure the AI only loads the specific context it needs for the exact task at hand. If the AI is building the database, it only gets the database files.
That makes total sense.
It's not about the AI lacking the intelligence to read a big document. It's about optimizing the AI's cognitive focus so it executes flawlessly without getting overwhelmed by irrelevant details.
Okay, that clarifies the setup phase. So the developer has finally spoon-fed the properly chunked blueprints to the AI. Now, the AI needs the tools to actually build the application. It needs hands.
Yes.
And this brings us to the MCP servers, or Model Context Protocol servers.
And this marks a crucial shift in the experiment. We move from just generating text to physically building functioning software systems.
Right.
The AI wasn't just typing out code into a terminal void. It was actively plugged into a variety of enterprise platforms. Yeah, the way to visualize this isn't an AI just typing on a keyboard. Think of the MCP servers as like universal translators at a massive United Nations assembly.
Oh, I like that.
Right, the AI only speaks text, but the MCP server translates that text in real time into the specific button clicks, API calls, and commands required to operate external software.
Exactly.
Let's look at the utility belt the developer equipped the AI with. One translator is plugged into GitHub, managing the code repository. Another is plugged into Figma.
Figma, wow.
Yeah. The AI is actually generating design tokens like specific hex codes for colors and padding sizes, which the MCP server translates into Figma components and eventually into CSS code that human designers can tweak later.
That's amazing. And for the backend logic, they utilized an MCP tool for N8N.
Wait, N8N, what is that?
N8N is an automation tool that handles backend API logic via visual workflows rather than raw code.
Oh, right. The developer specifically noted that using N8N avoids the nightmare of dark code.
Yes, dark code.
Dark code is what happens when an AI writes a million lines of dense, tangled back-end script that no human can decipher or audit, right?
Precisely. By forcing the AI to build in N8N, the AI creates visual nodes and logic flows. A human engineer can actually look at a flowchart on a screen and validate that the logic makes sense.
That is so smart.
And the tooling goes even deeper. They employed MCP tools for Neo4j.
Neo4j.
Yeah, Neo4j is a graph database, which is brilliant for mapping out complex relationships. It looks somewhat like a detective string board, connecting different pieces of data with lines.
Oh, cool.
This allowed the developer to visually zoom in and see exactly how the AI was connecting user data points. And for standard relational data, the AI was operating Postgres.
Man, my absolute favorite integration was Postman.
Oh, yeah.
As the AI was building the back-end APIs in N8N, it was automatically pushing the open API definition files into Postman, which is a tool developers use to test APIs. It populated all the endpoints in real time.
That synchronization allows for continuous automated testing alongside the development.
But wait, with the AI manipulating Figma designs, building graph databases, and creating visual workflows all at the exact same time, how does the human developer verify any of this is actually working?
Right.
You can't just trust the machine blindly when it has its hands in that many systems.
And that verification is where the developer applied behavioral-driven development, or BDD.
Behavioral-driven development. So instead of writing complex code just to test other complex code, the AI is writing plain English sentences about how the application should behave, right?
That is the core of it, yeah. Early in the process, the AI wrote what are known as cucumber scripts based on the business process flows.
Cucumber scripts.
Yeah, a cucumber script is literally a plain text description. It says things like, given the user is on the login page, when they enter a valid password, then they should see their dashboard.
Oh, okay.
From those plain English sentences, the AI generated Playwright scripts. Playwright is an automation framework that physically opens a web browser and clicks around to test the UI the AI just built.
Wait, really? So the AI is defining the test, building the software feature to pass the test, and then running an automated browser to prove to the human that the feature works perfectly.
Exactly. Stepping back to look at the whole picture, this transcends an AI merely writing code. The developer documented the AI provisioning infrastructure, setting up Docker containers, configuring external mail servers, and establishing SMS gateways for text messages. The AI is functioning as an entire DevOps engineering department.
It is a staggering amount of capability. But despite equipping the AI with this incredible suite of enterprise tools, the AI's underlying personality, its deep-seated need to vibe code, kept completely derailing the entire process.
Yeah, the fundamental friction between the conversational nature of the tool and the rigid waterfall workflow just reared its head constantly.
It became a massive roadblock. Like, the developer's dream was to have the AI just run a single master prompt, read the chopped-up markdown files, and build the app while the human drank coffee.
The dream, right.
Right. But Claude Code would invariably hit a minor discrepancy in the documentation. Maybe a variable was named slightly differently in two files, something that happens in literally every real-world project.
Oh, constantly.
Instead of just making a logical guess, the AI would pause its entire operation mid-task to ask the developer a clarifying question.
Because the model is aligned to be helpful and accurate. It expects a human collaborator to be sitting at the keyboard, ready to chat and resolve the ambiguity.
But the developer found this highly annoying. They explicitly did not want to chat.
Right.
To force the AI to stay on track, resolve its own issues, and maintain the strict waterfall timeline, the developer invented this bizarre, almost comical human-in-the-loop system.
It really is something.
It reminds me of that soul-crushing office job where an intern is hired just to manually copy data between two incompatible corporate spreadsheets because the boss refuses to buy integration software. The developer called it browser-to-terminal ping-pong.
And the mechanics of this workaround are a perfect illustration of where we currently stand with AI project management.
Let me walk you through how absurd this was. So the developers set up a Kanban board on Monday.com to track the project milestones, things like build database or design UI.
Okay.
They opened a standard Claude AI session in their web browser and connected it to the Monday.com board using one of those MCP translators. The browser AI acts as the project manager. It looks at the board, figures out what needs to be done next, and generates a detailed text prompt.
That provides the instruction set.
Right. Then, the human developer physically highlights the text prompt in the browser, copies it, switches over to their command line terminal where Claude Code is actually running, and pastes the prompt in.
Wow.
They hit enter. The terminal AI goes to work provisioning servers and writing code.
And inevitably, it stops to ask one of those clarifying questions.
Yes, which forces the developer to manually type out a quick fix just to get it moving again. But eventually, the terminal session finishes the task. The developer then has to copy the terminal's closing output log, switch back to the browser session, paste the log in, and essentially tell the browser AI, okay, here's exactly what the terminal AI just accomplished.
This is wild. So the browser AI processes that result, updates the state diagram on the Monday.com board to show the task is complete, logs any deferred architectural decisions, and then generates the very next text prompt for the human to copy and paste back into the terminal.
So what does this all mean? We have the most advanced computational technology in human history, and the human is literally acting as a manual copy-paste bridge between two different instances of the exact same AI, just to keep a project moving forward on a Kanban board.
Yeah.
It sounds incredibly tedious and completely counter to the promise of automation.
Oh, the developer freely admits how tedious it is, yet it perfectly encapsulates the growing pains of this technological transition. I mean, the AI is successfully writing excellent TypeScript. It's configuring complex Docker environments beautifully, and it's logging architectural decisions flawlessly. But it absolutely refuses to take the steering wheel for one big, long session without supervision.
Right. It won't just take the keys, drive across the country, and call you in at a ride.
Exactly. The irony is inescapable here. The human developer set out to implement a hands-off waterfall process, but ended up managing this incredibly powerful AI exactly the way a micromanager oversees a brilliant but easily distracted employee.
Yeah.
You have to give them one hyper-specific task on an index card, wait for them to finish, log their progress on the board, and then hand them the next index card.
It's exhausting just conceptualizing that workflow. But this deeply frustrating ping-pong process actually led the developer to a major realization.
Yes.
They uncovered a profound insight about how we should be instructing AI to build software, and it completely flips traditional agile software development on its head.
This particular insight might be the most practical, actionable takeaway for anyone listening who is looking to build complex systems with AI right now.
Okay, so in standard human-led development, we prefer to build in vertical slices.
Right.
If you're building a new e-commerce application, human developers don't build the entire database for the whole app first. You say, let's build the shopping cart feature. You design the database tables just for the cart, you write the back-end logic just for the cart, you create the API endpoints for the cart, and you design the user interface for the cart.
Exactly.
You build one complete functioning feature from top to bottom before moving to the next feature.
Because that vertical approach is the bedrock of agile methodology. It gives human stakeholders a tangible working piece of software to test and interact with early in the process.
But the developer concluded that if you have an upfront blueprint, a waterfall spec, asking AI to build in vertical slices is the exact thing causing massive slowdowns. Instead, you must instruct the AI to build horizontally.
And shifting to a horizontal build process changes the entire dynamic of the cognitive load placed on the AI.
Let me explain what a horizontal build looks like.
Yeah.
You have the AI build the full infrastructure and system design for the entire app first.
Okay.
Once that's done, it builds the full database layer and data model for everything.
Yeah.
Then it moves up a layer and builds the entire business logic layer using BPMN.
Right.
For our listeners, BPMN stands for Business Process Model and Notation. It's essentially a universal flowchart language that turns complex business rules into a visual map that both humans and software can read.
Perfect explanation.
Thanks. After the BPMN layer, the AI builds the entire API layer, then the full UI wireframe layer, and finally the interaction layer orchestrating all the user journeys.
It's a complete inversion of how human development teams usually operate.
But why? Why is the horizontal approach so much faster and more efficient for the AI?
Well,
I mean, if humans prefer vertical slices to stay organized and see progress, why does the AI prefer to build the entire invisible foundation before putting up a single wall or window?
it comes down to how AI agents manage context switching. When you ask an AI to build a vertical slice, say, that entire shopping cart feature, the AI acts as a planner.
Oh.
It looks at the feature, breaks it down, and has to rapidly switch contexts. It has to act as a database engineer, then immediately switch to being a back-end logic developer, and then switch again to being a front-end UI designer.
Wow. So it has to swap out its database brain for its user interface brain line by line.
Exactly. Constantly coordinating between those different contexts and different agent personas
Oh,
for every single feature creates massive computational overhead.
I can see that.
The AI loses its train of thought trying to juggle all those different technical disciplines at once. It's what makes the vertical process incredibly slow and prone to errors.
But with the horizontal approach, that context switching just vanishes.
Completely. One highly specialized agent persona can just blaze through a single layer of the technology stack.
Yeah.
The database agent focuses entirely on building the relational tables without ever having to think about what color the checkout button is.
Right, right.
The API agent just maps all the endpoints without worrying about CSS styling. Removing the context switching penalty allows the model to operate at peak efficiency.
You're letting the AI stay in the zone for that specific technology stack. It's assembly line logic applied to artificial intelligence.
The developer does include one crucial caveat to this strategy, though. This horizontal approach is strictly for the initial build phase, when you have a complete, comprehensive upfront specification.
Ah, okay.
Later on, when the foundational application is finished and you want to add a brand new feature, then you revert to a vertical approach.
Because the massive horizontal foundation is already poured and cured, adding a vertical slice later is just plugging into an existing system.
Exactly the dynamic.
So let's summarize the incredible journey we've been on today. We have seen that modern AI, even when forced out of its native vibe coding comfort zone, can absolutely build a highly complex application using a rigid, traditional SDLC waterfall approach.
Yeah, it really can.
We watched it digest raw meeting transcripts, map out C4 architectures, act as an entire DevOps team, write great code, and even write plain English tests to verify its own work.
The true bottleneck in the system is no longer the AI's ability to code, design, or provision infrastructure.
The bottleneck is the human.
Yep.
Specifically, the tedious manual session management, the browser-to-terminal ping-pong, required to keep a highly interactive conversational AI focused on a linear project plan.
And bringing this directly back to you, the listener, there is a profound lesson here about adopting any new technology. Whenever you're integrating a new tool, whether it's a generative AI model or a new piece of enterprise software, you have to critically ask yourself if you're losing massive amounts of efficiency simply by forcing it into an old framework. Are you trying to make a conversational vibe coder act like a traditional waterfall developer?
You have to adapt the workflow to the reality of the tool, rather than blindly forcing the tool to adhere to a legacy workflow.
Because if you fail to adapt, you end up acting like a glorified intern, manually copying and pasting text prompts between two windows just to stop a supercomputer from asking you perfectly reasonable questions about a discrepancy in your own documentation.
It is a wild reality check. But it leaves me with one final, slightly provocative thought for you to mull over. Throughout this entire experiment, the developer had to rely on visual translation tools.
Right.
They used N8N to visualize the back-end logic to avoid dark code, and they used Figma to see the UI, specifically to keep track of what the AI was doing. They needed those human-readable lifelines to maintain control.
Because the AI still requires a human manager to piece the broader architecture together and verify the steps.
Right now, yes. But think about the technological trajectory we're on. What happens when the context windows get so large and the attention mechanisms get so sharp that the AI can execute a massive, flawless, horizontal build from a single master prompt? What happens when it no longer gets confused by a 500-page requirement document? When it doesn't need to stop and ask clarifying questions? And it certainly doesn't need a human to copy-paste its progress between terminal windows.
At that point, it just reads the blueprint, translates its own instructions, and builds the entire house in one continuous, invisible session.
If the AI evolves to build the entire infrastructure, the complex graph databases, the back-end logic, and the user interface in the blink of an eye, Without ever checking in with a human translator, what happens to our human ability to even comprehend the systems that run our world?
Yeah.
We started this deep dive talking about the comfort of handing a blueprint to a master builder and walking away. But maybe the scary part isn't that the builder keeps texting us for approval. Maybe the scary part is what happens when they finally stop.
A fascinating and a slightly unsettling question to leave it on.
Thanks for joining us on this deep dive. We will catch you next time.